I'm Anil Kumar sharing solution of a question from my student Joseph. Joseph, let me first thank you for sharing such an excellent question, and I'm sure many of my viewers will benefit from its solution. We are trying to solve trigonometric equation. The one given here is in quadratic form. We need to solve 10 cos square x plus 3 sin x minus 9 equals to 0, where x is between 0 and 2 pi. So we are expecting the solution in radians within 0 to 2 pi interval. And since this equation involves sine and cosine both, we need to convert them in just one of them. As we know, that 1 plus, we can write like this. We know that sine square x plus cos square x is equals to 1. So we could write cos square x in terms of sine. So cos square x will be equals to 1 minus sine square x. Now that helps to write cos in terms of sine. Thereby we'll get a quadratic equation only in sine, right? So we'll replace cos square x by 1 minus sine square x. So now the equation can be written as 10 times 1 minus sine square x plus 3 sine x minus 9 equals to 0. Let's open the bracket. We have 10 minus 10 sine square x plus 3 sine x minus 9 equals to 0, which can be simplified. We can combine 10 and 9. So we have minus 10 sine square x plus 3 sine x. 10 minus 9 is plus 1 equals to 0. So there we have a quadratic equation in only sine. It's better to write with this leading coefficient as positive. So I'll multiply all these terms on both sides by negative 1. So we get 10 sine square x. Here we get minus 3 sine x minus 1 equals to 0, right? Now we can factor by writing minus 3x as 5 and 2 combination. Since the product is 10 times 1 minus 10, so we can get minus 10 by multiplying minus 5 by 2. So we could write this as 10 sine square x minus 5 sine x plus 2 sine x minus 1 equals to 0, right? So this helps in factoring the given equation. So at this stage, we have written minus 3 sine x as combination of these two. Now we can take 5 sine x common from first two terms. We get 2 sine x minus 1, and here just 1 is common, so we can just write this as 2 sine x minus 1 equals to 0. Now 2 sine x minus 1 is common, and we get 5 sine x plus 1 equals to 0. So we get this quadratic equation in factored form, and now we can find its solution by equating both these factors to 0. The first one is 2 sine x minus 1 equals to 0. The other one is 5 sine x plus 1 equals to 0, right? So these will give us different solutions. Here we are looking for sine x equals to taking 1 here, dividing by 2, and here we are looking for sine x equal to minus 1 over 5. Okay, so let's find out all the possible values of x in the given domain, which is 0 to 2 pi, where we can get these solutions. So let's begin with the first one, which is sine x equals to half. So sine x is half, that means sine x is positive. We are looking for solution for sine x equals to half. So we'll get two positions. Applying the cast rule, let me write down here. we know sine is positive in quadrant 1 and in quadrant 2. So there are two positions which can give us this result in the interval 0 to 2 pi. So one will be kind of here, the other one is kind of here, right? This acute angle, half, we could find from special triangles also, or we could use the calculator, right? So we could do shift sine inverse, that is 1 divided by 2 equals 2. So that gives us pi by 6. So this angle, one of them is pi by 6. The other one will be pi minus pi by 6. So we get two solutions here. One is pi by 6. The other one is pi minus pi by 6. Is that okay? Right? That means 5 pi by 6. So there are two solutions, pi by 6 and 5 pi by 6 for sin x equals to half. That is to say that the angles, this one and this one, right? This is for sin x equals to half. You could have also got the same result using your special triangle. Let me draw here one whose sides are 1, 2 and square root 3. And this is sine pi by 6, right? So this is pi by 6 angle, that's 90 degrees, 1 over 2. Now let's find the solution for the next one, which is, so we found one solution. Now the next one, next factor is yielding sin x equals to minus 1 over 5. Now sin x is negative in quadrants 3 and 4, right? So we're looking for a solution here, applying the same cast rule. So that means we're looking for a solution somewhere here. To find this, what we can do is, we can find related acute angle, let's say alpha, and then these solutions will be pi plus alpha and 2 pi minus alpha, right? So we have x equals to pi plus alpha and 2 pi minus alpha, right? So let's first find what alpha is. Okay, so we'll do sine inverse of 1 over 5. Since we are looking for the related acute angle, we'll take care of the sine later. Okay, that gives us approximate value, which is 0.20. So we found alpha as equals to 0.20. Let's take two decimal places. Okay, so in that case, x will be equals to pi minus 0.20, and the other one will be 2 pi minus, pi plus. The other one is 2 pi minus 0.20. So we have pi minus, plus pi plus 0.2, which is equal to 3.34, and here we have 2 pi minus, so 2 times pi minus 0.2 gives us 6.08. So in radians to two decimal places, those are the two angles, correct? So we found these solutions. One is this angle, the other one is this angle, correct? So we have four solutions for the given equation. The answers will be, so we can write, actually you could write all this in, because we got some in decimals anyway. Now let me keep them in exact form. Pi by 6, 5 pi by 6, this is from that one, and here we have 3.34, 6.08. However, it is preferred to write all of them in either exact form or decimal, right? So you can actually write them all in decimal form in your answer, correct? Let me redo this. So we'll have pi divided by 6 in decimals is, you could write this as 0.52, right? And if I multiply this by 5, I get in decimals 2.6, let's say 2, 3.34 and 6.08 as 4 different answers in radians for the given equation. I'm Anil Kumar and I hope that helps. So the idea here is, if you have a quadratic equation where you have 2 different trigonometric functions, write the equation in one variable, one type of function, then solve for the variable using factoring techniques. I hope that helps. I'm Anil Kumar. You can always share and subscribe my videos. Feel free to post questions and write comments. Thank you and all the best.